Good morning. This is Neil Polhemus. I want to welcome you to the second webinar in the series, which I'm calling Tips, Tricks, and Timesavers. Today's webinar will present several features in Statgraphics that I have found to be very helpful over the years, but that some of you may not yet have found. I mean, if you're like me, when you have a piece of software, you learn to do things a certain way, and you don't always, once you've managed to make it do what you want it to do, don't always go looking for necessarily more efficient ways of doing things. But there are several features in Statgraphics that I'd like everyone to know. Now, I know some of you have been using Statgraphics for 20 or more years. You may perhaps have found all the features I'm going to talk about, but we have a lot of new users of the program too, and I want to be sure that everyone sees these particular features, which I believe can make your life easier. Now, I'm going to actually talk about 7 topics this morning. 7 particular parts of the program that I have found to be very useful. The first topic will have to do with setting and saving system preferences. One thing you may have noticed about Statgraphics is that there are a lot of default settings that apply as you generate a graph or run a statistical procedure or whatever. We've taken the philosophy that we'd like to be able to generate output quickly and easily. So we don't ask you for axis scalings, we don't ask you for line types and colors. We basically just throw a graph up on the screen with certain defaults. You can always, once the graph has been generated, of course, go back and change those. But we find it very useful to be able, because we do generate so many graphs and so much output, to put it up using system defaults. Well, because of that, we need to make it easy for you to change the preferences, change the defaults. And one of the things I'll be talking about today is the different ways that you can change default settings for things like confidence intervals and the statistics that are calculated, the point types, line types on a graph, and so forth. The second topic I'll be talking about is recoding data. There's a procedure in the Statgraphics data book that allows you to convert numeric data to categorical data, which can be very helpful for doing different types of graphical presentations and also for running procedures such as an analysis of variance that expect data to be in categories. The third topic we'll be talking about has to do with making predictions from fitted models. Many procedures in Statgraphics take a set of data and fit a statistical model to it. Primary goal, of course, being able to take those fitted models and predict the value of future cases. Well, there is a method by which you can, while you're fitting the data, have it make predictions at levels of the predictor variables which are not in your original data set. And I want to be sure that you know how to do that because it's quite handy. The fourth topic we'll be talking about has to do with copying output to other applications. How do I get data, output, graphs, tables, numerical results, and so forth, from Statgraphics over to Word or PowerPoint or wherever I'd like to present it. The fifth topic will be overlaying graphs in the StatGallery. I don't know how many of you have found the StatGallery, but it's a place where you can put graphs side by side and also overlay graphs on top of each other to make graphs that are not necessarily built into Statgraphics. I'll be talking about using a by variable to replicate an analysis, to take a statistical analysis that you've already performed and very quickly apply it to different subsets of your data. And finally, I'll be talking about using value labels, which is a new feature in StatGraphics that allows you to allocate strings to numeric values in the data column. Okay. Now, the first topic will be that of setting and saving system preferences. As I said, there are various defaults that are set when you generate output in StatGraphics, and we need to make it easy for you to set your default preferences. Now, to illustrate that, I'm going to switch from my PowerPoint slides over to StatGraphics and call up a data set that I've shown you before. It's a data set having to do with the unemployment rate in the United States. I have data in a file here showing on a monthly basis the unadjusted and seasonally adjusted unemployment rates in the United States. If I wanted to do some forecasting, for example, of the unemployment rate, I might go to our new statlet that does exponential smoothing. The way you run this is you give it the column with the adjusted unemployment rates and tell it to plot the data by month, and it'll open up a new window where it's applied exponential smoothing. Now, that's simple exponential smoothing, not particularly appropriate for this data set. Holtz linear smoothing does better, and if I push the optimize button, you can see that if you tune the smoothing parameters in the exponential smoother, you get quite a good result in terms of tracking the unemployment rates. And here you see the forecasts for the next 5 months. The unemployment rate has been going down fairly nicely. The model suggests it will continue to go down, although with 95% confidence, it could at any point turn and start back up again. What I wanted you to see, though, is that in generating this output, various defaults have been automatically applied. I can change some of those defaults by going to the Edit menu and asking for the Preferences dialog box. The System Preferences dialog box sets a variety of options for you that are automatically applied to any analysis when it's performed. For example, you can see that by default, the confidence level that's used to do confidence intervals and prediction intervals and so forth is set to 95%. So by default, when this plot was generated, these prediction intervals here are 95% prediction intervals. Well, if you happen to be a 90% person or a 99% person, you can change that default. You notice also that the number of significant digits for output is set to 6. So if you look, for example, on the screen at the MAPE, there are 6 significant digits shown. If you look along the x-axis at the way it's displayed the months, it's displayed the month and year using 2 digits for the year. If you'd rather use 4 digits, you can always check this box here and use 4 digits instead. So there are a variety of options that you can set on the Edit Preferences dialog box that change the default output when a StatGraphics procedure is used. Other things that I find helpful, there's a Stats tab, for example, over here, where you can specify the statistics you want computed by default whenever StatGraphics computes a table of statistics. You know, I have mine set to the average, the median, the standard deviation, the coefficient of variation, minimum, maximum, quartiles, and some skewness and kurtosis statistics. If you prefer something else, you can change the checkboxes, and once you push the OK button, those will become the new defaults until you come back and change them. Other things you might want to change: distribution fitting. Here's where you specify the default test for normality, the general goodness of fit test, whether you like to do a Kolmogorov-Smirnov test or perhaps an Anderson-Darling test. On the capability tab, you specify the capability indices you like to compute whenever a capability analysis is done. And also of considerable interest is the text tab. You may have noticed that when StatGraphics creates tables, the most important statistics are typically shown in red. The general rule actually is any statistic talked about by the stat advisor will be highlighted in red. If you don't like that, you can uncheck the highlight references, or if you'd rather they were in some other color, you can pick green or blue or yellow or something like that. Okay. Now, we call these options sticky options. They'll be set until they're changed again. Okay. Nice thing about this, of course, is you can set your system up the way you like it. Okay. Well, that is a possible way to change options in the system, to go to edit preferences. Okay. There are other places where you can go to set preferences. For example, if you want to set the styles and fonts and colors and so forth used when graphs are created, then you want to set the graphics preferences. Now, StatGraphics maintains a set of default attributes that are applied whenever you create a new graph. In general, the way you override those for a particular graph is by pressing the right mouse button and selecting graphics options. I'm sure you found that if you've used StatGraphics at all. The right mouse button graphics options is a way to change the attributes of a single graph. You can also use the Profile tab on the graphics options dialog box, however, to save and apply other sets of attributes. It's a handy way to take a set of styles, line types, point types, colors, fonts, and so forth, save them away, and later apply them to other graphs. I'm going to show you how to do that in just a second. You can also import and export these settings to move them from one computer to another. For example, if you have a desktop where you run StatGraphics and also a laptop, you can set the preferences on one computer, export them, move a small little file to the other computer, import them into StatGraphics on the other computer, and have all your options stay the same. Okay, now let me give you an example of that. Let me go back into StatGraphics for a moment. You can see that when this particular graph was created, it uses a gray border. It uses squares for the points. It uses a blue line and so forth to connect up the points. If I right-click and ask for graphics options, it will bring up a dialog box where I can set, actually override, many of those settings. For example, I might decide that I'd like to make the background of the plot light green. So if I pick light green, press OK, and then apply, you'll see the background is set to green. If I'd like to add a grid to the plot, I can go to the Grid tab, select both, ask for a dotted grid, and press Apply, and now there's a grid on my plot. I might also want to change the type of the points. Right now they're squares. It's nice to fill them in sometimes. They're a little bit easier to see. The lines, well, right now there are 3 lines on the plot. There's a blue line, which is the smooth values of the points. There's a red line for the forecasts and a purple line for the confidence limits. If I like, I might want to thicken out some of those lines. Okay, I'm just going to make each one of those lines a little bit thicker. There we go. Okay, so I've made some changes. Right now, those changes apply just to this particular graph that I'm looking at. Suppose I really like this set of changes, though, and decide that I'd like to save this away. I can go to the Profile tab. The Profile tab is where I can save a set of attributes. The way you do it is you look for a user profile that hasn't been used yet, push Save As, and give it a name. For example, I'm going to call this set of options Smoothing. Okay? It's now saved these colors and styles and so forth in a new user profile called Smoothing. Now, the way that's used is that next time when I create a plot, okay, and let's create another plot. Let's create the same plot again. Okay, the adjusted data. Again, we'll use Holt's smoothing and perhaps optimize it. There we go. Could be any graph. If I now push the right mouse button, go to Graphics Options, and go to the Profile tab, I can pick that profile that I saved and push Load, and you can see that it immediately applies that set of attributes to the new graph. There are some default system profiles that have been saved. You can see the default profiles, even a black and white profile, but the one I just created is now saved. And I can apply that to any graph, and I'll get the colors, the styles, and so forth that I like. Okay. Very handy option. Now, another handy option is the ability to save the desired tables and graphs that are created whenever I run a statistical procedure. Okay. In StatGraphics, whenever I select a statistical procedure, I'm offered a set of default tables and graphs to create. And when you first get StatGraphics, for each procedure, there are a certain set of tables and graphs that come up by default. You can change that using the Store button on the Tables and Graphs dialog box. So, for example, if I'm doing a simple regression, and this is actually from the simple regression procedure, and I want to include a plot that's not included by default, I select it, I press Store, and then the next time I do a simple regression, I'll get that table and graph. Let me show you how that works. Let me just go back and find the simple regression procedure. Here it is. Relate one factor simple regression. Let me take those adjusted unemployment rates, plot them versus month, and ask it to fit a straight line. Not necessarily a good thing to do, but I just want to illustrate the option. In simple regression, you can fit actually various types of models, a linear model and various other models. Okay. And what you'll be offered by default, if you don't change it, is an analysis summary, unusual residuals, a plot of the fitted model, and residuals versus X. Well, suppose I'd like to be offered by default a plot of observed versus predicted. I check that, I press Store, And you see it says that the table and graph selection has now been stored as the new default. Okay. So now, if I ran this again, I should see, let me run it again, it should be offered by default a new set of tables and graphs. And there you are. The new set of default graphs for a simple regression now includes the observed versus predicted values. Okay, so it's a handy way, that store button right here, where you can save the graphs and tables that you want the procedure to generate by default. Okay. That's something I thought that perhaps some of you may not have found. Now, all of these defaults, these graphics defaults, the default tables and graphs, the confidence levels and everything, can be exported and sent to another computer. Okay? I'm going to show you in just a moment how to take the settings that I've created here, export it, and perhaps bring it over to my laptop. Basically, whatever settings, whatever default settings you select in StatGraphics may be exported into a little script file and then imported into another copy of StatGraphics. This actually lets you do two things. It lets you, as I said, move settings from one computer to another. It also lets you establish an organizational standard and apply it to everyone's computer in your organization. For example, you might want one person in your organization to pick a set of colors and styles and confidence levels and default capability indices and so forth. Save it as a script and then import those settings into everyone else's computer so everyone's output and so forth will look the same. Okay. Now, it's quite easy to do that. When you're in StatGraphics, and I'm back to StatGraphics again, you go to File, Export Settings. Export Settings allows you to export, as I said, graphics profiles, interface options, all the system preferences, fonts, even the shortcuts you have on your toolbar. It does it, incidentally, through a script. And if I push this little button over here that says Show XML, it'll show you a script that it will generate when I tell it to save my settings. You can see the script specifies different things, such as the statistics I'd like to calculate, and that user profile, that graphics profile, the smoothing profile, for example, that I just created. All right? That's just so you can see what's going to be created. If I want to export it, I push the OK button. Okay? And it will allow me to save my settings. And I'm going to save it to a webinar file. Okay, so it's now created a script actually called settings. Now, if I later take that little file to another computer, on the other computer I'll want to say File, Import Settings, go find the file that was just created, which was in my data directory, webinar, and it was called settings. And if I open up those files, those system settings will be imported into my new version of StatGraphics. Okay, so it's very easy for you to take the settings from one computer, export them to a file, and then import them into another computer. Okay. That can be very helpful. And particularly if you have a large organization and want everyone to be using the same sets of attributes, it's a nice way to take the settings and distribute them to everyone. Okay. Okay, that's what I wanted to tell you about system preferences. The second item I wanted to talk about today has to do with recoding data. StatGraphics, in its data book, gives you the ability to take data in a column and recode it in different ways. For example, something that I do a lot is take a column of numeric data and recode it by applying labels to different categories. This is easiest to show you by actually going ahead and doing it. So let me go back to StatGraphics. Let me just say File New, okay, to get back to an empty Statfolio, an empty data sheet. And I'm going to open up now a second data file. It's one called tensile strength. Tensile strength has a single column giving the tensile strength of samples of a product. I probably have this here because I'd like to do a capability analysis of it. Well, let's suppose for a moment that the specification for strength is 15 to 25. That's the allowable range for the tensile strength. I'm going to take this column and recode it by assigning a label below spec to anybody who is below the lower specification limit, above spec to anybody who's above the upper specification limit, and OK if you're within spec. Well, the first thing I'm going to do is actually take that column, highlight it, right-click, and say Copy. Now it asks what I want to copy out of that column. I'm going to tell it copy everything, including the names and comments. I'm then going to click on column 2, push the right mouse button again and say Paste. Again, tell it I have names and comments. And now you see it's created a second column with a copy of the data from the first. The reason I did that is I'm now going to recode the data in place, and I didn't want to destroy the original column. To recode the data, I'm going to highlight it, press the right mouse button, and go to Recode Data. This brings up a dialog box where I now specify the manner in which I want it recoded. I do that by taking particular intervals. In this case, I'm going to tell it take anything from 0 to 14.99 and recode that as below spec. Now you can spell it right, that would help, below spec. I'll take everything from 15.00 to 25.00 and tell it label that as OK. And then take anything from 25.11 up to, I think I'll give it an upper limit of 100 and recode that as above spec. Okay. It's now going to recode that data in place. Now, two things to watch for if you're doing the recode. The first is the limit conditions. You can specify limit conditions that tell it what to do with values that might be right on the boundary. By default, the limit condition says recode anything greater or equal to the lower value and less than or equal to the upper value. So anything between 0 and 14.99 inclusive is going to be recoded as below spec. I also have to tell it what happens for a value not within any of the limits that I specify. Do I want to leave it as is or set it to missing? I've covered all the values in the column, so it doesn't matter. I'm just going to press OK, and you can see that it's now recoded the data as either below spec, OK, or above spec. Why might I want to do that? Well, I might want to, for example, create a bar chart. I might want to now go to Describe Categorical Data Tabulation. If I take the Strength 1 column and now create a chart, you can see that it will show me how many observations were within spec, how many observations were above spec, and how many observations were below spec. There are actually lots of times when it's handy to recode your data so that you can display it in some other fashion. And the Recode Data in the StatGraphics data book lets you do that sort of thing. Okay, well that's a feature I think everyone should know about. Incidentally, I should invite you, as I always do, and I hope you realize this, to send me via the GoToWebinar facility any questions that you'd like me to answer at the end of this session. I will try to go for about an hour, show you the 7 things I want to show you, and then take questions. Okay, so if you have any questions, send them, and I'll get to them at the end of the presentation. Okay. The third topic I'd like to talk about is making predictions from fitted models. Many procedures in StatGraphics, as I'm sure you're aware, create statistical models based upon the data they're given. The procedures fit models to the observations that are provided. Those observations are sometimes called a training set. They're used to train the model, fit the model, however you want to phrase it, with the intention of using those fitted models to then make predictions for other observations that were not used to fit the model, either because you withheld them to do verification, or perhaps you simply don't have data for other combinations of your predictors. What I'm going to show you is how in StatGraphics you can use a procedure that develops a statistical model to make predictions for data points that aren't in your original data set. The way it's done, incidentally, is by adding rows to your data file in which you enter values for your predictor variables for your X variable, but leave the values of the dependent variable blank. If you give it the X's but leave the Y blank, the data obviously won't be used to fit the model, but the procedures in StatGraphics are smart enough, many of them, to then go ahead and give you predictions for those new rows. That's true of the regression procedures. It's true of the general linear models procedure. It's true of the design of experiments. It's true, I believe, of some of the discriminant analysis procedures and so forth. Okay. Let me demonstrate how that works, actually. Let's go back to StatGraphics, and let's say File New to close off that particular data set. And now I'd like to open a third data set. This is one that's supplied as a sample data set with StatGraphics. It's the result of a designed experiment, and it's actually called Chemical Reaction 2. What Chemical Reaction 2 is I believe, a fractional factorial experimental design with a few center points. The design itself has 19 rows. The 5 predictor variables are feed rate, catalyst, agitation rate, temperature, and concentration. The response variable is percent reacted. Okay. Now, let's suppose I took this data and you can see it's been automatically loaded into the experimental design wizard, and ask the wizard to analyze the results. Okay. By pushing the Analyze Data, that's the Step 8 button on the experimental design wizard, it will automatically go in and fit a statistical model. This statistical model involves the main effects and also interactions between all pairs of factors. You can see, for example, in the analysis of variance table, it's highlighted in red. I didn't turn that feature off. So it's still highlighting in red the factors and effects for which the p-values are less than 0.05 and therefore statistically significant. Okay. Now, one of the options in Analyze Experiment, if I push the Tables and Graphs button at the top, is to add a table of predictions. Okay. Here you see a table where StatGraphics has taken the fitted statistical model, and for every observation in the data set, it shows the observed value, the value predicted by the model, and then lower and upper confidence limits for the mean response at the combinations of factors associated with that row. And it's done it for the 19 rows in the original experiment. Now, suppose I want to use that model to make some predictions. What I can do is I can go to the bottom of my data sheet and type in, for example, an additional row. I'm going to add in a 20th row, and I'm going to set the feed rate to 14, the catalyst to 1.8, the agitation to 115, the temperature to 175, and the concentration to 5.5. Okay. This was a set of factors that wasn't in the original experiment. Now, at the same time, I'm going to leave the setting for percent reacted blank. That way, it can't be used to fit the model. Okay. When I now click back to the Analyze Experiment window, you'll see that the program has added a 20th row to its prediction table. No observed value, but the predicted percent reacted is 47.6. Confidence interval for the mean response between 71.9 and 77.4. Very handy feature that's used, as I said, in many of the procedures in StatGraphics. If you want not only to fit the model, but also to make predictions at combinations of the X's that are not in the original data set, what you do is you add additional rows to your file, put in the X variables, but leave the Y variable blank, and the program will automatically make a prediction for that new row. And you can put multiple rows in. I just put in one, obviously, to give you an idea. Okay. That's something that you all should know about. Now, let me go back to my PowerPoint presentation and move on and see what other applications I wanted to talk about. Well, the fourth item I wanted to talk about today has to do with copying output to other applications. StatGraphics creates tables, it creates graphs, it creates numerical results. And while they might look nice in StatGraphics, eventually we're going to want to get them out, put them in Word, put them in PowerPoint, put them in Excel, put them someplace so we can present them to other folks. Well, there are several methods in StatGraphics for getting output out of the program. The obvious method, at least most obvious to me, is to do a copy and paste. When I'm in StatGraphics, I can always push the right mouse button, copy whatever I'm looking at to the Windows clipboard, and then go to some other application and paste it. I can also, though, in the case of graphs, save the graphs as image files. I can actually take a graph and save it, for example, as a PNG file. That's real handy if I need to send the graph to a journal for being published. On the other hand, while I can copy and paste single graphs and tables, if I wanted to take all the output from a statistical analysis and move it, for example, to Word at one shot, then the StatReporter becomes a very handy way to do things. Okay, so let's go back to StatGraphics and let me show you some of those methods. Okay, let's start with a graph. Okay, here's a very interesting graph, right? It's a standardized Pareto chart for percent reacted. Incidentally, if you've not seen the standardized Pareto charts yet, any bars to the right-hand side of this line are statistically significant at the 95% level. Any bars to the left-hand side correspond to effects that are not statistically significant. Let's suppose I wanted to take this graph now and put it into Word or PowerPoint or Excel or something like that. The easiest way to do that is click your right mouse button and say copy. Okay. What that does is it puts it on the Windows clipboard. Okay. I'm now going to come back to my computer and call up Microsoft Word. Okay, where's Word? Here it is. It's on my other screen. I'll need to pull that over for you. Okay, I'm now in Microsoft Word. I'm going to do a, let's see, where am I? Oh. Actually, let me create a new blank document in Word. Okay. And what's it doing? It wants me to edit the header. Well, let's see. Let's say paste, paste. There it is. Okay. All I have to do is go to the paste option on the Word menu, select paste, and the graph is put into the Word document. Now, when things get pasted either into Word or PowerPoint or Excel, they're pasted as metafiles. That means you can nicely resize them and you won't lose the quality of the plot. Okay. You can do that with graphs, you can do that with tables, you can do that with numeric values. That's just a simple copy and paste. Okay. That's one way to get data and graphs and tables and so forth out of StatGraphics. Another way, let's bring StatGraphics back up again, to get a graph out is to push the right mouse button when you're looking at a graph in StatGraphics and say Save Graph. Save Graph allows me to save my graph as an image file. And a new feature in StatGraphics that we just recently put in is a feature that allows you to specify not only the size of the graph, but now also the target dots per inch. If I push my right mouse button and say Save Graph, I can then tell it, first off, what DPI I want, what size I want. And then I can pick from a JPEG file or a TIFF file or a PNG file or a BMP file or a GIF file. Specify the name of the file. I'm going to call it Graph 4, push Save, and it's now saved my graph in a PNG file with the desired dots per inch and size. I could now go to any other program, typically do an insert image, and it will pull that image and put it into the document. Okay, so with graphs, I've got a couple choices. I can copy and paste, or I can right-click and save it as an image file. Let's suppose, on the other hand, that I didn't want to just take one graph and put it into Word, but I wanted to take this entire analysis and put it into Word. The best way to take all of the tables and all the graphs from an analysis and bring it someplace else is, while you're in the analysis, push the right mouse button and say Copy Analysis to StatReporter. The StatReporter is another window that's always open in StatGraphics. You can see on the navigation bar to the left that there is a choice for the StatReporter. And what's just happened is it's taken all of the graphs and all of the tables and automatically pasted them very nicely into the StatReporter. Now, the StatReporter is actually a version of WordPad running inside StatGraphics. If you right-click and ask to save the StatReporter as, you can save the contents of that window as a rich text file, as an RTF file. That's a file that you can then bring into Word very easily. You just open it up into Word. It's one of the file types that Word supports. In other words, if you want to take the entire contents of an analysis, move it to Word, you first copy it to the StatReporter and then save it as an RTF file. Or you can incidentally copy everything to the StatReporter, highlight it, and do a right mouse copy, and then you could paste the entire contents of the StatReporter into Word as well. So you've got quite a few options. StatReporter is pretty handy for doing that. Okay. Let's go back, if we can now, to my PowerPoint presentation. I want to show you, here we are, another item that you all should know about. Another feature of StatGraphics that people, I think, eventually find, but maybe not right away, is something called the StatGallery. The StatGallery is a place where you can take graphs created by different analyses within the program and either paste them side by side or overlay one graph on top of another. It can be a very handy thing to be able to do. For example, let me go back to StatGraphics. Let's close off this particular data file. Okay. Close that all off. Minimize the StatReporter. And now open another data file. This data file is going to be called Nonlinear. This is a data set actually out of a book by Draper and Smith called Applied Regression Analysis. It's an example of a data file from a stability study, a study in which they took samples of a product at different numbers of weeks since it was produced and measured the amount of available chlorine in each of the samples. I think you can see just looking at the data that as the product ages, the amount of chlorine goes down. Well, Draper and Smith actually postulated a nonlinear model that would be useful to fit to the data. And if I go to relate multiple factors nonlinear regression, I can fit the model that they specified in their textbook. The dependent variable is going to be the chlorine. The way nonlinear regression incidentally works is you give it a y variable and then you give a function that you want it to fit. The function in this case will be a plus parens 0.49 minus a close parens times exp open parens minus b times open parens weeks minus 8 close parens close parens. Now that may look like a fairly strange model to you. It is the one though that the chemists thought would be appropriate for their particular data. Okay. It turns out, and you'll see in just a moment, that it's not that strange a function when you eventually see it plotted out. So I'll give it chlorine and I'll give it the model. Now incidentally, StatGraphics will parse that model. Anything it recognizes like weeks or exp, it'll know what to do with. Anything it doesn't recognize like A or B will be treated as unknowns in the mathematical model. Right. I'm now going to push OK. And it's noticed that there are two parameters, two things it doesn't know in that model, A and B. Well, it's going to suggest initially some values to use to start the search. A nonlinear regression is a search procedure. It's usually a good idea to give it good initial estimates, at least get the sign of the coefficients right. In this case, it doesn't matter. It's really a very simple function. I'll push OK a couple times, and here is the model that it actually fit. It turns out that it's an exponential type of an equation forced to go through the point 0.49 at 8 weeks. So I assume they took all the samples and diluted them, did what was necessary at 8 weeks to make the chlorine 0.49. And now it decays exponentially to an asymptotic value of A. So the A in the equation is the asymptotic value. Okay. Now, what's particularly interesting, I've always thought about this data, is first off, the model fits quite well. Secondly, though, there appear to be a couple unusual data points right here at 18 weeks. You've got this point right here and this point right here. I'm wondering just how much impact those points actually have on my model. Now, a good way to show it is actually to use that StatAdvisor. I'm going to right-click and ask it now to copy this pane to the StatGallery. Did I say StatAdvisor? I meant StatGallery. I'm going to copy the pane to the StatGallery. Now, what the StatGallery is, it's a place where you can put graphs side by side. Okay? Right now, there appear to be 1, 2, 3, 4 positions in the StatGallery. I'm going to right-click, though, and tell it to arrange the panes and ask for one position only. I'm not going to put them side by side. I'm going to put two graphs on top of each other. I'll now right-click, do a paste. And here you can see I've pasted the graph from the analysis window into the StatGallery. Now, let's go back to the analysis window. Let's try taking out these data points. I'm going to click on the first data point, go to the analysis toolbar, and hit the plus/minus button. It now took it out and refit. I'm going to do the same thing with the second point. So it's now refit the model without these two data points. So we can see the difference. I'm going to right-click, go to Graphics Options, go to Lines, and change the color of the line to red. Okay? So red's going to be the line without those 2 points. I'm now going to right-click, copy the pane to the StatGallery. That'll immediately bring me back to the StatGallery. Actually, when you copy the pane to the StatGallery, it puts the graph on the clipboard and puts the focus on the StatGallery. I can now right-click, do a paste. And it gives me the option to replace what's there or overlay. I'll say overlay, and it now puts the red line on top of the blue line. Incidentally, if they happen to have different scales, it would adjust the scale of the second to fit the first. Now, what you can see here is actually that those 2 points that were removed have very little impact on the fit. They're not high leverage data points. They just pull up that line a little bit in the vicinity of 18 weeks. But in terms of the general fit of the line, those points really don't have too much influence. The ability to overlay graphs in the StatGallery lets you actually create all sorts of plots you might not be able to create within a single StatGraphics procedure and get very interesting types of effects. Okay, well, that's something I was hoping everyone would know about, the StatGallery. Very useful. And the nonlinear regression is a good example. Topic 6, repeat analysis by. One of the features that we put into StatGraphics not too long ago is the ability to repeat a statistical analysis for subsets of your data. Let's suppose, for example, I went and fit a regression model to a large data set. I can then take that same fitted model, that same mathematical model, and have it fit to various subsets of my data using a feature in StatGraphics called repeat analysis by. To show you how this works, let me go back again to StatGraphics, save file new, and close off everything I've done so far. Get back to an empty data sheet. For this example, I'm going to open up a data file from the World Bank. You may have seen this data file in some of the previous webinars. This is data with various demographics for most of the countries in the world. It's data from 1961 through 2010, including things like population density, life expectancy, and then some economic variables like GDP, per capita GDP, for example. Let's do a regression initially using all the countries in the world. Okay? And then after we've done that, have it fit the same regression for each region. You'll see that there's a column here labeled region, which classifies the location of different countries: Africa, Europe, the Middle East, and so forth. Okay? So I'm going to first do an analysis of the entire data, and then I'm going to repeat the analysis by each region. Okay? To do that, let's just go ahead back to simple regression. Tell it I want to relate one factor simple regression. Okay. Now, what do I want to fit? Well, I think I'll fit total life expectancy, make that the y-axis variable. The x-axis variable, I'm going to choose GDP per capita. But I know that GDP per capita varies a lot, so actually I want to fit life expectancy versus the log of GDP. The way I do that is I type LOG open parens. Now, you might think the next thing I'm going to do is double-click on GDP. Unfortunately, if I just double-clicked on GDP, it would overwrite what I've already typed. What I'm actually going to do is I'm going to type LOG open parens and then hold the control key down and double-click on GDP per capita. If you hold the control key down and double-click on a variable name, it doesn't wipe out the field. It just appends the name of the variable to what you already typed in that field. That may be something that you didn't know. If you're building a StatGraphics expression, you can hold the control key down, double-click, and it won't wipe out the field. Now, I'd also like to do this only for a particular year, so I'm going to type year equals 2009 in the select field. All right, let's press OK. We'll press OK. We'll press OK. Take all the defaults on the way in. And you can see now I've gotten 2 tables and 3 graphs. This is for all the countries of the world. Now, I'm not saying that's necessarily a great fit. I think if you look at that, you may still see some curvature present, either curvature or perhaps different mechanisms for different countries. Anyway, there is a simple regression done on the entire data set. If I now want to repeat that analysis for each region of the world, I go to Edit, Repeat Analysis By. That will allow me to do this same analysis for every unique value in some other country. For example, I'm going to tell it now, repeat the analysis by values in region. There's also a checkbox, which I normally keep checked, that says hold axis scaling constant. That means use the exact same scale for all the graphs for each region. If you didn't check that, it would adapt each graph to that particular region, which I don't want to do. I'll now press OK. It will tell me your request will generate 8 windows. Do you want to proceed? And I said yes. And what it now did, here I'll move this over for a second so you can see what it just did. I'll slide this over, is it created 1, 2, 3, 4, 5, 6, 7, 8 new windows, one for Asia, one for Central America, one for Europe, one for the Middle East, and so forth. Okay? And now if I click on any one of those, you can see the window for a particular region. A very nice, quick way to repeat an analysis for each unique value of some categorical column. Okay, that's something I've used a lot. Now, The last thing I've used a lot that I want to tell you about is value labels. Value labels are a new feature added to version 17 that lets you assign strings to each unique value in a numeric data column. Now, the reason you might want to do this is that it's a lot easier if you have a lot of data to enter numbers like 1, 2, 3, 4, and so forth into a column than it is long strings. With the value labels, you can enter numeric values, but when tables and graphs are created, have the numeric values replaced with labels. It's something that was asked for a couple years ago by folks that were analyzing survey data. You know, in survey data, it's very typical to have integer values, you know, rate something on a scale of 1 to 5, but then to want to give a name to each of the levels. I thought we could do a simple example here. Suppose I went out and did a survey and asked 500 people to taste a new type of ice cream and have them rate it as either excellent, very good, good, mediocre, poor, or horrible. What I'd like to do is I'd like to enter data into Statgraphics as like 1s, 2s, 3s, 4s, 5s, or 6s, but then have the results appear as excellent, very good, good, mediocre, and so forth. Okay? Pretty easy to do with your value labels. So let's go back to Statgraphics. Let's clear out the data sheet, get back to an empty data sheet. I'm now going to go to column 1, double-click on it, which will bring up the Modify Column dialog box. This is a column that I'm now going to call Opinion. I'm going to leave Opinion as a numeric column. But before I finish with this dialog box, I'll go to the right and push Value Labels. This is where I go to assign labels to numeric values. For example, I'm going to tell it the value 1 will correspond to excellent. So I'll type in 1 excellent and push Add. 2 will be very good. Push Add. 3 will be good. 4 will correspond to mediocre. 5 will correspond to poor. And 6 will correspond to horrible. Okay? Fine. I'll push OK a couple times, and now I have my opinion column. I'm now going to enter some numbers into my column, numbers between 1 and 6, corresponding to the opinion of someone. Now, I'm not going to do 500 of them. You get the idea. I put in the numbers 1 to 6. And now suppose I want to do a tabulation. Now suppose I want to go to Describe, Categorical Data, Tabulation. I'll put in opinion for my data, press OK a couple times, and voila. The bar chart comes up not with 1s through 6s, but with the labels excellent, very good, good, and so forth. You can also, by the way, push the right mouse button. There is a check mark for Use Value Labels. With the right mouse button, I can turn the value labels on and off if I like. That's a way of saving a lot of time. Rather than having to type excellent, very good, good, and so forth into the column, I just type 1s through 6s and use the value labels to create the plots that I want. Okay, well that is the last topic I wanted to show you. Let me remind you that we do record these webinars. And if you want to see this webinar again, or you want to see some of the many other videos that I've made, the way to do it is the following. You go to www.statgraphics.com. And several places on the home page, you'll see a button that says Watch a Video. Push that. You can complete the form and press Go to Video, which will take you to a long video all about version 17. But if you click on Watch Another Video, it'll take you to a page where we've listed the webinars and other videos that we've created. So I invite you to do that and hope that these 7 items will give you some tools to save some time as you're using StatGraphics. All right, now I'm going to look at the questions that have been entered and see if there are some questions that I can answer. Okay, let's see what questions I have. Well, one question that was asked, what does the extrapolate button do in the recoding data dialog options dialog box? Okay, well, that's an interesting question. If we go to the empty data sheet like this, let's suppose I had some data that I wanted to recode. Okay, let's open, for example, well, let's do tensile strength again, right? That has values of strength going from 0, well, actually from about 15 up to 50, something like that. Okay? You remember the way I recoded strength before is I first copied it and pasted it into this data set. I'm sorry, into this column. I then highlighted the column, pushed the right mouse button, and went to recode. There is an extrapolate button down here, an extrapolate checkbox, which will allow me to extrapolate the recode for certain types of recodes. For example, let's suppose I said I wanted to go from 0 to 10 and make that a 1. Recode anything between 0 and 10, a 1. Between 10 and 20, a 2. Between 20 and 30, a 3. I believe, and I haven't done this in a long time, but I believe if I put the extrapolate button on and do a recode, it should think that 30 to 40 will be 4 and 40 to 50 will be 5 and so forth. And that's exactly what it did. Okay? You see, it took that recode and extrapolated it. It saw a pattern. 0 to 10 was 1, 10 to 20 was 2, 20 to 30 was 3, and it was able to extrapolate it and recode 51, for example, as being the 6. It's another handy option. It wouldn't have worked if I was recoding as character data, but if I'm recoding numbers and making them numbers, it may be able to see a pattern and extrapolate it. Okay. Let's go back to the top. Oh, I actually have quite a number of questions here. Okay, first question. Why does every StatGraphics graph have a large and wide frame around the plot that takes place? When this graph is copied and pasted on a PowerPoint slide, the plot itself is small, surrounded by a large empty frame. Is there a way to reduce the surrounding space? Okay. That's an interesting question. Let me open up a data file, a sample data file, and talk about that for a second. We'll open up Nonlinear. Let's just do a simple plot here. I'll do a scatter plot of chlorine versus weeks. Okay. What the comment states, if I understand it right, is that there is a lot of blank space in this graphics window around the actual plot itself. Let me tell you what the reason is that we leave the blank space. First off, we want to have space, enough space for the tick marks. These tick marks here are rather short. They go from 0.38 to 0.5, but sometimes we have character labels over here. Sometimes we have 2 lines of a title. Sometimes we have a legend over here. It's left space for those graphs that need that kind of space. Now, for a particular graph, you can always move things around. I can always drag a label if I want. I can also, by holding the left mouse down on a graph, drag it toward the upper right corner, and then grab the lower right corner and expand it. Well, that's a little too much. Okay? So if you have a particular graph and you want to expand it, you can do that. That will expand the graph. Now, if you want that to become the new default, okay, so that the next graph is that same size, you push the right mouse button, you go to Graphics Options, and then to Profile. Pick a user profile to save it as, and at the same time, check the box Make Default. That will take the current settings for the graph and save it as the new default. Now, I don't want to do that, but if you did, that is the way to change the default size of your graphs. You go to a particular graph, you enlarge it by dragging it around, make it the size you like, and then save a user profile, clicking Make Default, and that will become the new default size for your graphs. Okay. You can also, if you don't like the colored border, if you right-click, go to Graphics Options, there's a border button where I can, for example, set the border to white. Then when it appears, for example, in PowerPoint, it won't have that gray border around it. I hope that answers that question. When this graph is, here's a second question. When this graph is copied and pasted on a PowerPoint slide, the plot itself appears small, surrounded by a large empty frame. Okay, same question. I just showed you how to reduce the frame. Okay, on the recode, 25.01, not 25.11. Did I type 25.11? I certainly didn't mean to. We went through, I have to start this back up again. Okay, hang on. Let me start my PowerPoint presentation back up again. When we did a recode of the data, I meant to tell it to start the recode of the second class at 25.01. There seems to be someone that pointed out that I may have done 25.11. Okay, this is the recode, I believe. See if I can get it on the screen for you. I'm sorry, I'm not having much luck getting to the right page. Give me just a moment. Here's the recode. Get it up. There we go. This is the way I meant to do the recode. 0 to 14.99, 15 to 25, and 25.01 to 100. Sometimes I don't type what I say. That's how I meant to do the recode. You can see that these classes are right next to each other, so no one would be excluded. I apologize if I type 25.11. Is it possible to recode text data into numeric values? Sure. I can do that kind of recode as well. If you want to recode text data into numeric, the way you do it is this. Let's actually open up another data file. My favorite data file, car data, 93 cars. Here it is. Okay. What might we want to recode? Well, here, for example, is a column. It's called drivetrain. It has front, it has rear, and it has all. If I want to recode this, I'll push the right mouse button, go to recode. And I can tell it, for example, to recode anything between front and rear and make it a 1. And anything between all and all, make that a 2. Now it does it alphabetically with respect to the limits. So anything between front and rear should become 1, all to all should become 2. And that's exactly what it did. Here are the fronts and the rears, they've become 1, and here is an all-wheel drive car, it's become 2. So yes, you can use the recode to go from numeric to numeric, character to character, numeric to character, character to numeric, any way you want to do it. What have you done wrong when you are typing data into a column and already define the column name and formula, but still get an unrecognized variable column 1? Okay. Well, let's see. The unrecognized variable error message typically comes when you've done an analysis using one column name and then change column names. For example, let's type a little bit of data into column 1. Okay, it's now called column 1. Let's go to describe numeric data one variable analysis. Ask it to do an analysis of the data in column 1. Okay, here it is. It's a one variable analysis on column 1. Now suppose I go back here, double click, and change the column name to X. What happens when I go back to the one variable analysis is it's now going to say, oops, I don't recognize my input variable anymore. It says unrecognized variable column underscore 1. What you have to realize is that in StatGraphics, everything is hot. This one variable analysis dialog box is linked to the data book. Whenever changes are made in the data book, it sends a message to all windows, please update your output. And once you click back on that window, it tries to update it. In this case, it says, I don't know what column 1 is anymore. Well, I can fix that. I can go back to the data input dialog box and change it to X instead. It knows what X is. But you see, once I made that change from column _1 to X, because everything works by parsing what's in these data input dialog boxes, if whatever you typed in that field is no longer a valid name or a valid StatGraphics expression, it's going to say unrecognized variable. Okay. Next question. How do I get the additional statlets that you have in your version? By version 17, I guess. These were all added to version 17. If you have version 17, you should have all of those statlets. There's nothing new there. I mean, there's nothing added after version 17. We're working on some new statlets for version 18, but they're not available yet. These are all out-of-the-box statlets for version 17. If you don't have statlets on your menu, then you're not using version 17. You're using some earlier version. Is there a way to send the StatGallery to a Word document? That's an interesting question. If I copy a graph to the StatGallery, copy and paste it, there is no direct way to take that and put it in Word, not the whole thing. I can always take a single graph in the StatGallery and copy it to the clipboard and paste it into Word. But I don't believe that there's a way to take that entire page and automatically copy it to Word. You have to do it one graph at a time. That's a good idea, though. I'm going to write that one down for version 18, the ability to copy the entire StatGallery at one shot to Word. I mean, I could have taken this single plot I had done before and copied it by right-clicking and say copy, and then go to Word and do a paste. But I can only copy a single pane at a time from the StatGallery. Good question. Good idea. It would be a nice addition to the next version. How can one temporarily exclude a few rows from an analysis? Well, that's an interesting question, too. Let's do something. This is something that not a lot of people know. I'll show you something fairly interesting. Let me open a relatively small data file, something like Nonlinear. Remember Nonlinear? That's the stability study. I have chlorine as a function of weeks. Normally, if I do a regression and I don't put anything in the select field, it'll fit the entire data set. Okay? There's the entire data set. Suppose I had particular observations that I wanted to exclude. Let me put the mouse down on this one. That's row 17, and the mouse down on this one, that's row 18. Suppose I wanted to refit without rows 17 and 18. Now, I could always use the plus and minus on the analysis toolbar to exclude them. But I'm going to do it a different way. I'm going to go back to where I specified the input data. And in the select field, I'm now going to type exclude 17 and exclude 18. Exclude 17 means exclude row 17. exclude 18 means exclude row 18. And I'm going to combine them, I believe this is right, with an ampersand, which I believe will exclude both. We'll find out really quick. Exclude 17 and exclude 18. Yep, that did it. See, they're gone. The 2 points that were right here were gone. So the syntax for excluding a single point is just exclude with its row number. To exclude 2 points, you say exclude 17 and exclude 18. Let's suppose, though, I had a bunch I wanted to exclude. Okay? What I can do, if I wanted to exclude a bunch of rows, is I can go in and create a brand new Boolean column. Okay? And I'm going to, for example, create a column, and I'm going to call it included. Okay? I'm going to type zeros and ones in this column. Ones for the points I want included, zeros for the ones I don't. So actually, let me just start by typing in some ones. And actually, oh, there's a way to do that. Let me go actually to generate data and say count from 1 to 1. No, let's say 1 to 1 to 1 by 1, and reshape it into a column of length 44. If you were here for the last webinar, you saw me using certain operators. Here are two operators, reshape and count. Count from 1 to 1 by 1. I'll just give me the number 1. Reshape it into a column of length 44. That actually filled out this column with 44 ones. Now I'm going to go down and put in a few zeros. Oops, zeros. I'll put in zeros for the rows I don't want to include. Okay, so I just took out 4. So now I have a Boolean column. It's got ones and it's got zeros. If I go back to my simple regression, go back to the select field and put in the column name included, it'll pick up the rows with ones and it'll exclude the rows with zeros. So you can see now, for example, it says the number of observations is 40. That's probably something that a lot of you have not realized. What goes into the select field is a Boolean expression, something that results in 1 if true, 0 if false. I can go and create my own Boolean column with ones and zeros. And if I put that Boolean column in the include field, it will select only the rows that have ones. Well, actually, all rows that don't have zeros is how it works. If it's a 0, it throws it away. If it's anything else, it keeps it. Normally, though, I'll use it as a Boolean, ones for include and 0 for exclude. Interesting question. That's how you can temporarily exclude a few rows from the analysis. Does StatGraphics offer multidimensional scaling? Not at the moment, but I wouldn't be surprised to see that in the near future. Is it possible to drill down to multi-level categories when doing the by function? For example, by country, by phones, per capita, or by gender. I don't know an easy way to do that. When you repeat an analysis, it repeats the analysis using all unique values in a single column. It's not possible to actually specify two columns on that particular dialog box, but I'm also writing that down as a very good idea for version 18. Let me just make a note here. Repeat analysis using two by variables. Now, truthfully, once I've done a repeat analysis, you remember that I repeated the analysis for the World Bank data by region. I could go to any one of those new windows, let's say the one for Europe, for example, and do another repeat analysis by. So if I took the European window, I could split it up by some other category. But then I'd have to go to the Asia window, split it, and the North American window, split it. So I could do it by a sequence of multiple splits. But it might be nice for the next version to have two by variables on this dialog box. Okay. Another question. Hello, I used to make GLM analysis, for example, independent variables AB, dependent variables A, B, C, D. How can I do an export to the whole analysis? Because when I click on the pane and copy the stat reporter, it only copies whatever variables are shown in the pane at the moment. Okay. Yeah, that is an interesting question. There are certain windows, certain panes, which give you a choice of output. For example, see if I can remember one that does that. Perhaps multiple regression. Let me call back that car data set again, 93 cars. Let's do a multiple regression here real quick. Let's do highway miles per gallon versus, oh, let's say horsepower, luggage, weight. Just three variables to start off with, okay? Let's add to this the residuals versus X. Okay, this is residuals versus horsepower. Now, this is a particular plot where I could plot versus horsepower, and I could plot versus luggage, and I could plot versus weight. The comment that one watcher was making to me was that, you know, if I do this and I do a copy analysis to StatReporter, it copies everything that's currently visible, including the residual plot versus weight, but it didn't give me residuals versus horsepower because that wasn't showing at the moment. So they wanted to know whether there was a way to output to the stat reporter some of the other windows that might not currently be showing. No, I don't think there is. And I will also write that down and give that some thought. When you copy to the stat reporter, you copy everything that's currently showing. Now, this next question, though, may be a solution to it. The next question by a user is, what is the stat log? Well, the stat log is a window that keeps track of what's happened during the session. Right now, it's kept track of all the different data files I've loaded, etc., etc. The stat log, though, is also a place where I can output windows. So, for example, suppose I've done a residual plot versus horsepower. If I hit the log button, it put the graph in the session log, which means if I go to the session log, you'll see that it copied that graph, residuals versus horsepower, to the session log. I can now plot it versus weight instead, push the log button again, and the session log now has both of those plots. It has the plot of the residuals versus horsepower and residuals versus weight. So there was no way using the StatReporter to get those two plots at the same time because they required your changing pane options, and only one is visible at any given time. But you could selectively make those plots, send it to this log file, and then save the log file. The log file is in many ways like the StatReporter. Okay, you can save it just the way you save the StatReporter. It's also an RTF file. So it can also, this stat log, be pulled up into Word and edited in Word if you want to edit it there. Okay. Here's another question. Incidentally, I'm going to answer questions as long as people keep sending them. I see that almost everybody who started with me at about an hour and a half or so ago is still with me. That's nice. I am happy to keep answering questions as long as you keep sending them. I will understand if people leave. It's been a long time. And I thank you, incidentally, for logging in. I hope what I've told you has been useful. Let me keep going down the questions, though, as long as people have them. There are only two tabs, A, B, and C, in the data book. How do I insert other tabs, and is there a limit? Yes. There is a limit. It's 26. Currently, it says tabs A, B, and C. You can have up to 26 tabs A through Z. The way you get more is you go to Edit, Data Book Properties, and there's a setting for number of active sheets right at the top of Data Book Properties. Okay, so I just changed it to 6. Now I have tabs A through F. It's not as it's done in Excel. You can't click on the tab and ask for more. You do it by going to Edit, Data Book Properties, and asking for more sheets. Okay, the plus minus button is not always available. Why not? Well, it's only available on some procedures. That is true. Simple regression, for example, was a place where when you were on a graph, the plus minus button would exclude data points. In other procedures, and the questioner mentions analysis of variance, for example, it's not active. We are slowly adding that feature to various procedures. Some procedures, it doesn't make a lot of sense. Some, to be honest, we just haven't put that facility in yet. It does require special coding within each analysis to make sure that it operates properly. We've put it in pretty much all of the regression procedures because it's very natural to want to look at a plot of a fitted model, for example, and say, I'd like to exclude that data point. But there are other procedures where it might be useful that we haven't implemented it yet. We will eventually get to all the procedures. And so if it's not active, if it's grayed out, then that feature is not available in that analysis. Okay, someone says that a better way to exclude data values would be to be able to click on the rows and just ask for them to be excluded. That is something that we've been working on rather than the way that we've done it until now. It would be nice, I do agree, to, for example, be able to click on a data row and do something to set that as an excluded row and have that excluded from all of the analyses. You can expect to see something like that in the near future. I do appreciate that comment. Let's see. GLM question with multiple plots. Can we use an XLL script for that? You know, I was thinking about that. What you may not know, and what I'm going to talk about, I believe, in the next webinar, are Statgraphics scripts. If I do some sort of an analysis, let's suppose I do a simple regression, and I ask it to fit chlorine versus weeks. And actually a good model for this particular data is the square root X model, which I'm pretty sure is here, but I'm not seeing it right at the moment. Square root Y, there it is, square root X. And you select various output. When it generates an output, some tables and some graphs, there is associated with that window a script, an XML script. You can actually see the script if you push the right mouse button and say Show XML. It actually shows the output, not the output, the instructions that could be used to generate that output. Actually, it would be better if I showed you, if I did a multiple regression. Let me pull back my car data file for just a second, and let's just quickly do a multiple regression. Let's do highway miles per gallon versus horsepower, length, and wheelbase, for example. And I'm going to ask for residuals versus X. The XML script right now tells it that I want to do a graph of residuals versus X. And it uses horsepower, which is the default variable, unless I override it, for example, with wheelbase. Then the script says, do a residuals versus X graph using variable 3. It didn't say that before because the default was 1. The questioner suggested that I might be able to add another statement to the XML script telling it I also wanted a residuals versus X graph against the first variable. I think I can only have an entry in there once for any particular type of graph, but I'm going to check. And I think in the next webinar, you've now given me a good idea. I wasn't sure what I'd do for the next webinar. I think I'm going to talk about XML scripts because they are a way that you can set up an analysis that you want done, and using a simple text editor, add or change particular features in that output. Okay, so let's do the scripts in the next webinar. I've gone for almost 2 hours now, and I think I'm going to have to stop. And that does seem to be the last question. Could we have output more than one plot, more than one residual plot using scripts? Let's put that on hold. I'll talk about that in the next webinar when I talk about XML scripts in general. Well, thank you all for your attention. Thank you all for the many questions that you sent. Questions and comments are welcome at any time. Just send your ideas and questions to support@statgraphics.com. Someone will answer it, and if there are interesting ideas for the next version, they'll typically get sent to me, and we'll be putting them on the schedule for additions to version 18. Thank you. I hope you found this webinar useful, and I'll see you all again in about a month. So long.